equations of motion 1. The first equation is v equals v0 plus at. This equation tells us the final velocity of an object. It starts with an initial velocity, represented as v0, and accelerates at a constant rate, a, over a period of time t. The second equation is y equals s0 plus v0t plus 1/2 a t squared. This equation calculates the position of the object, as, after a certain amount of time, t. It takes into account the starting position, s0, the initial velocity, v0, and the acceleration, a. 3. The third equation is v squared equals v0 squared plus 2as minus s0. This equation is useful for finding the final velocity squared without needing to know the time, t. The fourth equation is v equals 1/2 times v plus v0. This gives the average velocity of the object, assuming the acceleration is constant. Real-life example. Stopping a car. Let's apply these equations to a real-life situation. Imagine you are driving a car at 20 meters per second, which is your initial velocity, or v0 equals 20 meters per second. Suddenly, you see a red light ahead and hit the brakes. The car decelerates at a rate of equals -4 meters per second squared. The question is, how far does the car travel before it comes to a complete stop? Step-by-step solution. Step 1. What is given? We know that the initial velocity, v0, is 20 meters per second. The final velocity, v, is 0 because the car comes to a stop. The acceleration, a, is -4 meters per second squared because the car is slowing down. Step 2. Which equation should we use? We need to find the distance traveled, s0. Since we do not know the time, t, we will use the equation v2, v over 2 plus or 2as, 0. Step 3. Plug in the values. We substitute the known values into the equation. 0 squared equals 20 squared, plus 2 times -4 times s minus s0. Step 4. Simplify the math. First, calculate 20 squared, which equals 400. So the equation becomes 0 equals 400 minus 8 times e minus s0. Add 8 times the difference between s and s0 to both sides to get 8 times the difference between s and s0 equals 400. Finally, divide both sides by 8 to get the difference between s and s0 equals 50. Step 5. Final answer. The car travels 50 meters before it comes to a complete stop. Exercise for you. Now it's your turn to solve a problem. Here's a question to try. A ball is thrown straight up into the air with an initial velocity of 15 meters per second. The acceleration due to gravity is equals -9.8 meters per second squared. How high does the ball go before it stops momentarily? Hint: use the equation v squared equals v0 squared plus 2as minus s0 and assume the starting position, s0, is 0. Write your solution step by step and share it in the comments. This is a great way to practice and apply what you've learned. Remember, these equations of motion are used in all kinds of real-world scenarios, from understanding how cars stop, to calculating rocket launches, to predicting how far a soccer ball will travel. By mastering these, you're learning a powerful tool to solve motion problems. Feel free to share your solutions to the exercise in the comments, along with any questions you might have. Also, let others know if you found this explanation helpful by liking, sharing, or subscribing for more educational content. Have fun exploring the physics of motion.